In this question, we're told that the points A, B, C and D lie on a circle. CDE is a straight line. We're told that line BA is equal to BD, CB is equal to CD, and angle ABD is equal to 40 degrees. We need to work out the size of angle ADE, giving a reason for each stage of our working. Now let's start by looking at triangle BAD. We know that the line BA is equal to the line BD, and so we can say that triangle BAD is isosceles. Now in an isosceles triangle, we know that the base angles are equal. We also know that angles in a triangle add up to 180 degrees. Now if the base angles are equal, angle BAD is equal to angle BDA. Now given that angles in a triangle add up to 180 degrees, we can say that angle BAD, or angle BDA, is equal to 180 take away 40, all divided by 2, giving us an answer of 70 degrees, which we can now label in our diagram. Next we can move on to the quadrilateral ABCD. Now the quadrilateral ABCD is a cyclic quadrilateral, because all 4 points lie on the circumference of the circle. Using our knowledge of circle theorems, we know that the opposite angles of a cyclic quadrilateral is equal to 180 degrees. Angle BAD and angle BCD are opposite angles in a cyclic quadrilateral, and so we can use this in order to find BCD, because we already know what BAD is. So we can say that angle BCD is equal to 180 take away 70, which is equal to 110 degrees, which we can also label in our diagram. Next we can look at the triangle BCD. We're told that the line CB is equal to the line CD, and so we can say that triangle BCD is isosceles. Now given that triangle BCD is isosceles, we know that the base angles, angle CBD and angle CDB, are equal. And so we can say that angle CBD is equal to angle CDB, which is equal to 180 take away 110, all divided by 2, which is equal to 35 degrees. And so we can add this to our diagram. Now finally, we can use all the information that we found in order to find angle ADE, which we've labelled as theta on our diagram. We're told that line CDE is a straight line, and we know that angles in a straight line add up to 180 degrees. Now we can use this to find angle ADE. Now on the straight line, we have 35 degrees, 70 degrees, and theta. We know that all 3 of these angles must add up to 180 degrees. And so we can say that angle ADE is equal to 180 take away brackets 35 plus 70, close brackets, which is equal to 75 degrees. And so we've found that the size of angle ADE is equal to 75 degrees. Now this question is worth 5 marks, so let's take a look at where each mark is allocated. We get the first mark for saying that angle BAD is equal to angle BDA, which is equal to 70 degrees. We get the second mark for the correct justification, and this is because base angles are equal and angles in a triangle add up to 180 degrees. We get the third mark for saying that opposite angles of a cyclic quadrilateral are equal to 180 degrees. Now we get the fourth mark for using this fact in order to find that angle BCD is equal to 110 degrees. And we get the fifth and final mark for finding angle CDB and for using the fact that angles in a straight line add up to 180 degrees, and for therefore finding that the size of angle ADE is equal to 75 degrees, allowing us to get the full 5 marks needed in this question.